Subscribe now.
You are welcome once again to today's tutorials. This tutorial we are going to focus on DFT, which is inverse discrete Fourier transforms. In my previous tutorial, we talked about how to compute or do a direct computation of discrete Fourier transform when 2 points are given and also when 4 points are being given. So based on that, we assume that the signal is already in frequency domain. Or let's take this for instance. Assuming that you want to do something or process a signal in the digital domain, and for that matter, you converted it to the frequency domain using discrete Fourier transform. Now you are done with whatever processing that you want to do, and now you want to get it back to time domain. So what do you do? So the method that we want to talk about here is the inverse discrete Fourier transforms. And as I discussed in my previous video, the inverse discrete Fourier transform can be expressed mathematically as x of n will be equal to 1 over n summation of k equal to 0, n minus 1, x of k exponent j 2 pi over n k, where n is equal to 0, 1, 2, and so on up to n minus 1. So this is actually the mathematical expression for inverse discrete Fourier transform. Now let's solve some bit of example. So assuming that you have 2 point discrete Fourier transform, which is DFT. So let's take the first example and solve it. We have x of k to be equal to 2 and then 0. Now, using the formula 1 over n summation, that's x of n equal to 1 over n summation of k equal to 0 to n minus 1, and then x of k exponent j 2 pi over n k. We have n equal to 2, and then that's the number of elements, and then as I said earlier on, k has been given, and then n has also been given. So since n is equal to 0, 1, 2, 3, 4, let's express or compute them by putting everything into the formula. So now for n equal to 0, we will have x of 0 equal to 1 over 2 summation of k equal to 0 to n minus 1, x of k, and then exponent, because n is equal to 0, it's 0 here. So now if even k equal to 1, when we put k in, since n is 0, we are going to still get 0. So now whatever is going to be like for k equal to 0, we are going to get something like x of 0, but remember that we have the 1 over 2 here, x of 0 exponent 0 plus x of 1. So even if k is also 1, since n is 0, we are going to get still exponent 0, and therefore per this one we are going to get 1 over 2 multiplying by x of 0. X of 0 is 2, right? And then 2 times 1 is 2, right? And then going forward, we are going to get the other one to be what? X of 1, right? We are going to x of 1. The x of 1, and look at this point, the x of 1 is 0 over here. So since x of 1 is 0, we are going to get plus 0 into bracket 1. So when we simplify it, we are going to get 1 over 2 multiplied by 2, which is equal to 1. Let's take the point at which n is equal to 1. So if n is equal to 1, we are also going to get x of 1 equal to 1 over 2 summation of k equal to 0, n minus 1, and then x of k exponent. Since n is 1, we are going to get something like j pi and then multiply by 1. You get it? So based on this, x of 1 is equal to 1 over 2. So for k equal to 0, we are going to get x of 0 exponent 0 plus for k equal to 1, we are going to get, because don't remember that k is here already. So for k equal to 1, you're going to get x of 1 exponent j pi. And then when you do exponent j pi, you are going to get 1. So x of 1 is equal to 1 over 2 multiplied x of 0 is 2 multiplied by 1 plus x of 1 is 0 and then j is 1. So in this case, still we are going to get 1 over 2 multiplied by 2, which is equal to 1. And therefore, we can say that our x of n is equal to 1 and 1. So if you remember that when we were solving the 2-point DFT, we solved a question like that. So let's look at that particular question. Looking at the 2-point DFT, this is that particular question, the first question. So looking at the first question, we got something here as 2, 0. This is telling us that this discrete Fourier transform can also be reversed. After sending it to the digital domain, frequency domain, you can get it back to the time domain. So this is kind of the same as analog to digital conversion, and also the inverse one is digital to analog conversion, which is DAC, right? So now that we have been able to solve the first example, I'll leave the rest of the questions for you as a trial question. I'll leave the rest of the questions for you as a trial question. The next one is this one. This is the question that we did from our first example, right? This is the question. So the answer that you are supposed to get for this particular question is supposed to be 5 and 8. And then the answer that you are supposed to also get for this particular question, yeah, this the first one is 5 and 8, and then the answer that you are supposed to get for the question, which was the question is the 0, 2, it's also supposed to be 1, -1. So please try your hands on this for the inverse discrete Fourier transform. And if you have any question, please don't hesitate to put them in the comment section.